Hi folks, in this video I'll be giving you some tips for using C++ and Unreal Engine. When I first started out, I always thought I was doing something wrong. I could never get things to compile, nothing seemed to work right. Now I know that's just how it is. I want to give you new folks some confidence that you're not necessarily doing things wrong. Most of these tips deal with debugging, which is at least 80% of my time using Unreal Engine. But number 5 is a 60-second debug loop, which I hope will help you all, reduce that time. We have 10 tips here I'll go through, and just hope these tips are helpful. So let's get started. Okay, tip 1. I call tip 1 the sandwich build problem because some builds give you enough time to make a sandwich and watch TV. It's really a design constraint. Unreal Engine offers something called live coding that is supposed to speed things up. In the editor preference, you can turn it on, but be warned, live coding is fragile and should only be used for simple changes. If you add a new class, you need to do a full rebuild using Visual Studio or whatever you're using. I know this table is hard to see. If you want more details on any of these tips, please let me know in the comments and I'll do a full video on it. So other things to think about to speed compiles is the include what you use rule. Beginners, and maybe the rest of us, tend to put tons of includes in their header files just to make sure that we have everything. That really slows down the build. Instead, use a for declaration so your compiler has to do less work. Then finally, the obvious. Use solid state drives as much as possible. And maybe the not so obvious is also to turn off your virus scan. Only if you're willing to take the risk. Turn off the real-time antivirus scans for every file. During a build, Unreal spits out thousands of intermediate files. If your auto virus scan is on, this massively slows things down. Okay, tip 2, the odd couple of blueprints in C++. Okay, they're meant to work together, not replace each other. But you need to have a plan or you have a messy project. Don't feel that you have to use just blueprints or just C++. Blueprints help to speed development and really help when it comes to designing your project and tweaking everything to get it just the way you want it. But sometimes you need to use C++ for speed, especially when it comes to a large number of objects running every frame. There are also functions, advanced UI functions like Slate that require you to use C++. Also, you can create code in C++ that shows up in blueprints, giving you the best of both worlds. And you can add variables that show up in your details panel. But I can't say this enough. Don't let anyone tell you if you're not using C++, you're not a good programmer. That is not the truth. Tip 3, make IntelliSense work. So what is IntelliSense? In Visual Studio, it's your code helper. It provides autocomplete and parameter hints, along with tooltips and other things. It helps you code. But sometimes IntelliSync gets out of sync and you get errors saying unknown symbol, and it shows that you have an error in your code even though it compiles fine. But it doesn't mean C++ is broken. It just means your index is probably out of date. One easy way to get back into sync is to regenerate your files. And I'll show you how to do that here. There is an alternative to Visual Studio, and that's Rider for Unreal and Visual Assist. Visual Studio is the default, but it might not be the best. Many Unreal pros, which I'm not one of those, switch to Rider once projects get really big because of the productivity boost. It outweighs the licensing cost, but it's all up to you. Okay, tip 4, the build.cs file. So what exactly is the build.cs file? Every module in Unreal, whether it's the engine itself, a plugin, your game code, it all has a build.cs file. This file is written in C# and is used by the Unreal Build tool to figure out how to compile and link your code.
If you're coming from a regular C++ programming background, you can think of the build.cs kind of like the makefile. It describes dependencies, includes paths, and includes the build settings. The difference is that Unreal abstracts a lot of the hard work for you, whereas the makefile is a pain in the butt. Okay, here in the build.cs file, you'll see the PCH usage. This controls how precompiled headers are used. And you'll notice two important sections within that, which is the public dependencies and the private dependencies. For the public dependencies, these are modules your code exposes to others, so it's open for everybody. If another module includes your header, then it can also use these dependencies. Now for private, these are only used inside your module and not exposed to anything else. This distinction helps Unreal figure out what it needs to recompile and keep things efficient. Some of the most important and most common modules are the ones you see under the public dependencies, like Core, which is the foundation to Unreal, Core UObject, which is Unreal's reflection and object system, Engine, which is the gameplay framework, Input Core, which is, of course, input handling, and then Slate, which we went over earlier, which is Unreal's UI system. If you want more details on the build.cs file, I do have a guide through a link in the description where I explain each module. In fact, I have 5 survival guides in that download covering the more complicated tips. So please check that out. Okay. Now, what if you want to use a third-party library or DLL? You have to put that in the build.cs file as well, and you have to include the path. For example, if you were integrating a physics DLL, you'd add its header and link against the lib file here. This is how you extend Unreal with external code. One thing I'd like to stress here is never hard code your path to your files within this build.cs file. Make sure you use macros, because any time you compile it and want to use it on another machine, it's probably not going to work. Okay, now let's talk about debugging when it comes to this file. If you get a link error, like an unresolved external symbol, you might want to think what you did in the build.cs file or didn't do, what you changed. It is probably the build.cs file. Again, if you want more detail on any of these topics, please just tell me in the comments and I'll do a standalone video on it. Tip 5, a 60-second debugging loop, which I do have a more detailed guide covering this because I'm just here showing you the high-level stuff, so not to bore the viewer and to get through all 10 of these tips. Okay, step 0. Okay, in Visual Studio, enable the Microsoft Symbol Server so your stack traces show real function names. Also, in the Epic Game Launcher, install the editor symbols for debugging for your Unreal version. This makes your debugging experience much smoother and a lot less cryptic. Step 1. Attach the Visual Studio debugger to the Unreal editor and drop in some breakpoints. This lets you pause the game exactly when something happens, so you can inspect variables, object states, and step through your code line by line. Think of this like freezing time in your game world and looking at what's happening under the hood. Step 2. Clean up your logging. Unreal generates tons of log spam, so create a custom UE log category. This gives you a quiet log lane that only shows the messages you care about. No more wading through pages of noise. Just a clean stream of your own debugging info. Step 3, guard assumptions. In C++, we often assume things like this pointer will never be null or this array always has at least one element. By using the ensure message F, Unreal checks those assumptions at runtime. If they fail, you get a clear error message and a stack trace showing how you got there. The best part, the game keeps running so you can keep investigating without the crash stopping you cold. Step 4. Use the visual logger. Record a 5 to 10 second capture and you'll get a timeline you can scrub through. It shows AI decisions, movement paths, and even custom notes and shapes you've logged for each frame. This is like the black box flight recorder for your game. Instead of guessing what happened, you can actually rewind and see the exact sequence of events. Finally, step 5. The gameplay debugger. Hit the apostrophe key in a game, and it lets you lock onto an AI. From there, you can see live categories like movement, perception, and decision making, all rendered right in the game. This is a great way to peek into your AI's thought processes while everything is running in real time. That is the Unreal Engine debugging loop. And there's a lot of devil in those details. I went over at very high level. But with these tools combined, debugging becomes a repeatable process instead of a guessing game. Tip 6, which is very similar to tip 5, you will crash the editor. It's inevitable, and it's also the best learning tool you have. I also have a guide for this process if you're interested. Step 1 in this process is your mindset. Crashes in Unreal, C++ are normal. Don't panic. It doesn't mean you're a bad programmer. We have some tools. Don't rush to restart the editor. Take a breath. Let's go to step 2. In step 2, get a clean call stack. If you set up your environment like discussed in the 60-second debug loop, you're all set. When there's a crash, you have what you need. For step 3, find the first function that's yours. It's probably at the top of the stack. That's your anchor point. It's the last piece of code that ran before Unreal fell apart. From here, you usually know what part of your system caused the issue. For step 4, classify what type of crash it is. Almost every Unreal crash falls into 4 groups: null or dangling objects, lifetime or order of destruction, threading violations, or invalid container access. Once you recognize the pattern, the fix becomes much easier. Step 5 is adding a guard. You'll remember this from the 60-second debug loop. Unreal gives you 3 quick guard tools. You can use those, or, you can just fix your code. And finally, step 6, rerun the game. You don't have to restart the editor every time. Just hit live coding, rebuild, run again, hit play, and re-trigger the same situation. And you're done. Tip 7, you will break your project. At some point, your project will crash and it won't open. It happens to everyone. Months of work gone. That's why version control is non-negotiable. In my mind, there are 2 most common version control packages I would use. Git with the LFS, large file storage, if you're a solo or small team, and Perforce if you're a bigger team or plan to be a bigger team. You're going to want to track your source, your config, and your content folders. But ignore things like intermediate and any cache folders. Those regenerate. I can't stress this enough. Version control is important. And remember, commit small, commit often, and version control turns a broken project into a 2-minute rollback, not a disaster. Please use it. Tip 8, plugins. Here I want to talk about one of the biggest time traps in Unreal, and that's reinventing the wheel. Unreal Engine already ships hundreds of powerful system tools. Please don't reinvent something that already exists. For example, input handling. Please don't hard code in key presses in C++. Unreal's enhanced input system handles everything. Key binding, multiplayer input, and even context-based actions. Instead of writing if key equals W, just bind an input action and let the system manage states and devices. It's faster, it's cleaner, and works across controllers automatically. Next, here's saving and loading.
Unreal already gives you the uSaveGame class. Serialize any variable, save it to disk, and load it back later. You don't need to write your own file phraser or JSON serializer. And finally, tags. When working with AI or gameplay logic, Unreal Gameplay Tags system is your secret weapon. You can tag actors, abilities, or even status effects like stunned or poison. Instead of adding a dozen bools to your class, just query the tags. It's cleaner and it integrates directly with gameplay ability system. The bottom line is, before you code, check to see if Unreal already ships this. At least for me, even if it's experimental, it's going to be better than anything I can write. Tip 9, the community. After hours of fighting link errors and battling crashes, you come to, I've tried everything, nothing works, I give up. Then you think, well, maybe someone else has already had this problem. Spoiler alert, they did, probably years ago. And they probably posted it on a forum, a Discord, or Stack Overflow. Welcome to your survival lifeline, the Unreal Engine community. Tip 10, math and transforms. Let's clear up what Unreal means by units and what it expects in certain math functions. In Unreal, 1 Unreal unit equals 1 centimeter. That's super important when it comes to importing from Blender, because Blender's grid units are 1 unit equals 1 meter. So if you don't scale your export, your assets show up 100 times too small in Unreal. Now, the big math got you. Degrees versus radians. In Unreal, most rotation values like F-rotator, the blueprint rotators, and editor gizmos, they all use degrees. But math functions like sine, cosine, and tangent all expect radians. And radians don't equal degrees. But Unreal gives you an easy way to fix this. There's degrees to radians and radians to degrees. In blueprints, you'll find degrees to radians and radians to degrees conversion nodes. The bottom line is, if things in your project aren't rotating right, not looking right, check your units. And now the bonus tip, macros. If interested, I do have a guide on this subject as well. Macros are how C++ code exists in Unreal Engine. The Unreal Header tool scans your macros and generates the glue code that makes your class visible to blueprints, garbage collection, the editor, and serialization. That's why generated body is required in every reflected class. And that's why your generated.h must be the last include in your header file. In plain C++, a macro is just a text replacement, like define pi as 3.14159. But Unreal uses macros for a much bigger purpose. They mark up your classes so that the Unreal Header tool knows what to reflect, what it needs to be visible to the engine. So macros don't change how C++ compiles, but they tell Unreal how to generate metadata about your code. There are 3 core macros you'll see constantly in your code: uClass, uProperty, and uFunction. Together, these macros are what let Unreal's editor, garbage collection, and blueprint systems see your code. So to sum it up, macros are the secret handshake between C++ code and Unreal Engine's systems. Master them, and you'll unlock everything from editor customization to full blueprint integration. And there you have it. The 10 tips and bonus for Unreal Engine using C++. Thanks for making it to the end. Please consider supporting the channel, where I have these 11 tips plus 11 more, plus 4 additional guides. Happy coding.